Hello, and welcome to this session on Chain of Responsibility Design Pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The chain of responsibility is a behavioral design pattern that provides a way to pass a request along a chain of potential handlers until one of them handles the request. The pattern decouples senders and receivers of a request, allowing multiple objects to have a chance to handle the request without explicitly knowing which object will handle it. When a client sends a request, it is received by the first handler in the chain. This handler examines the request and decides whether it can handle it or not. If it can, it processes the request and completes the handling. If not, it passes the request to the next handler in the chain. This process continues until a handler handles the request or until the end of the chain is reached. The chain of responsibility pattern promotes loose coupling between senders and receivers, as neither needs to have direct knowledge of each other. It allows for flexible and dynamic handling of requests, as the chain can be modified or extended at runtime. Hello and welcome back. Let's take an example code of a simple implementation of chain of responsibility design pattern. And in this code, we're going to be starting with an abstract base class, and the abstract base class is going to have a contract, that is the abstract implementation or interface, that on initialization takes in a successor, and that successor actually is a handler. It's a handler that is optional. I'm not going to be using type inting here, so I'll just put it this way. And this is a handler, and this handler is initialized at this point. The handler interface also have an abstract method that is the request handler that handles the request that is passed across the handlers. So now I'll create a concrete handler, and the concrete handler implements the handler interface contract that we have here, and also implements the request handler as is defined here. It expects a parameter, so we check if the request, that is the request parameter here, is A. That's what we're checking against. If that's the case, we'll print out the request is handled at handler A. And if this handler has a successor that is not known, then it should say the handler 1 is not handling this request, because right here, if it is A, if the request is A, it should handle it. If the request is not A, and it should check if there is a successor. If there is a successor, it should pass the request to the successor request handler method. So the request is passed to the successor request handler method. And here we define similar implementation for other concrete handler. This is concrete handler 2. And in concrete handler 2, we also define the request handler. And in concrete handler 2, we're checking if the request, the parameter entered is B. If it is B, then it should say the request is handled at B. And if it is not, then it should say handler 2 is not handling this request, and it should pass the request to the next handler. That is, if handler 2 has a request handler attached to it. So I'm going to do for the third one now, and basically I'm just going to change this to 3, change this to C, and change this to 3. That is, again, this is the third request handler, and it handles the request if the request entered is C. If it is, it will say request is handled at handler 3. And if it has a successor, it should pass the handling to the next handler. This time, I'm just going to end it here as the last handler. And I'm going to move this right here. That is, if it has a successor, then it should handle. But because this is the last one, it doesn't have a successor, so it's just going to come here and run handler 3 is not handling this request. And I'm also going to put up an output saying request handling is terminated, because this is the last request handler. Now let's do the client. And in here, I'm going to instantiate handlers, handler 1, 2, and 3. And then I'm going to say handler 1's successor is handler 2, and handler 2 successor is handler 3. So right now I've specified the successor for the 2, and now I can work on handler 1 and run the request handler and pass in a request, say C or B. When we run the code, you will see that because we passed in B, it tried to run it with handler 1, and handler 1, it says handler 1 is not handling this request, and then it says B is handled at handler 2. Basically what it did was that it tried to handle the request here. It says is request A is not A, so it passed that request to the next handler, and the next handler, the successor handler for handler 1 is handler 2, so it passed it to handler 2, and then handler 2 checked and saw that is B, and then handled the request. If we put it to C now, you will see handler 1 is not handling the request. It tried handler 1, and then it passed it to its successor, which is handler 2. Handler 2 is not handling the request, and then it passed it to handler 3, which is C. It is handler 3 that handled the request. And of course, if you have A there, A will handle the request immediately. But if you have something like F, which is not existing, it's going to show you that handler 1 didn't handle it, 2 didn't handle it, 3 didn't handle it, and then it terminated. Request handling was terminated because there was no handling. So what we've been able to achieve is that we have several handlers walking through the request to see if they can handle it, and when they can handle it, that handler handles it. And we can run this code this way, or we can actually loop the handlers. Let me comment this out and then create another handler 1. That is, you can say concrete handler 1, and it takes a successor, which is also a handler. You can pass that in here as the second handler, and then it takes the second handler also takes in handler 3 as a successor, and you can see the code continues to run the way it is. If I put B here, it's going to show that handler 1 didn't handle it, is the second handler that handled it. So either you run it this way, you loop in all the handlers in there, or you can just specify it this way depending on how you want to do it on runtime. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with Real-World Code Examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, catch, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video, and you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.